So Faraday's law of electromagnetic induction is the basis of all generators that use turbines basically to rotate a coil through which electricity is induced or voltage is induced, and the current will flow if you connect a load to the turbine or load to the generated voltage. Um, the counterpart of generator, which are motors, the basis of motors is Lorentz force. Remember, there's no really difference between motor and generator, except generator takes mechanical power for turbine to rotate the coil and to induce the voltage. That is, mechanical power is converted into electrical power. On the other hand, motors, they take electrical power. You connect the motor, if it's a DC motor, you connect it to the DC battery. If it's an AC motor, you connect it to the AC supply. So they take electrical power and they convert that electrical power into mechanical power. That is, the shaft of the motor is going to be rotated, which is connected to some load. So electrical power is converted into mechanical power. So motors and generators, their structure actually is exactly the same, only the function is opposite. So Lorentz force are the basis of the working of electrical motors. And what is Lorentz force basically? What does it states? Anytime you have a coil or a conductor that is carrying electric current, and you place that conductor in magnetic field, inside a magnetic field. Now you have an electrical field established by the flow of current, and you have a magnetic field established by, let's say, a magnet. When these two fields interact with each other, then the coil experiences a force, and if the coil is free to rotate about an axis, then a torque is produced which will turn the coil about the axis either clockwise or counterclockwise based on in which direction the force is acting. So that's what we call Lorentz force. So again, what is Lorentz force? Anytime a coil is placed in a magnetic field and the coil is carrying electric current, a force is going to be acted upon the coil, which will try to rotate the coil about an axis if it is free to rotate, and this force, or in general try to move the coil, and this force is called Lorentz force, and that's the basis of electrical motors. How do you calculate the Lorentz force? This is the formula to calculate the Lorentz force. Again, it's a vector quantity, and it is F is equal to I L cross B. Now observe that L cross B is the cross product operation, and there is no dot product between I and the vector that will be produced when you take the cross product between the length vector and the magnetic flux density. You are simply multiplying the magnitude of current by L cross B. Remember, force is a vector. So you calculate, you multiply, you take the cross product between the length vector, and again, length vector is what direction you're going to choose for the length vector? The same direction as we discussed in the last topic, the direction in which the current is going to flow. That direction is going to be the positive direction of the length vector. And since the current direction is generally given to you, because there is no Lorentz force if there is no current in the conductor, so you will know in which direction current is flowing. So you can easily establish the direction vector for the length. And of course, magnetic flux density depends upon in which direction the magnetic flux is acting, and you will see that either it is given to you, or you can establish that based on where is the north pole of your magnet, where is the south pole of your magnet, as we will study shortly. So once you carry out this operation, you are going to get the force vector, which will be a vector quantity. The magnitude of that is going to be the force that is acting on the coil, of course, and the direction is going to be perpendicular to direction of both length vector and magnetic flux density. Remember, anytime you take the cross product between two vectors, the vector that will produce as a result of that operation always have the direction which is perpendicular to both the vectors that you perform the cross product on. Okay. So if length vector and magnetic flux density, if they are perpendicular to each other, remember when you take the cross product, remember the operation is what? L magnitude of L magnitude of B sine of the angle between L and B. Let's call this theta. So if L and B are perpendicular to each other, sine will be sine of 90, which will be 1, and that's the maximum force that will be applied on the wire if the wire is sitting perpendicularly with respect to the direction of the magnetic flux density. And if you have that, then your equation is going to be reduced to F is equal to I L B, and this is the equation that is given in your textbook as well. Again, as I said, they're not going into the vector analysis, so they all only consider the optimum cases. So this is the textbook equation as well, which is given in your textbook. Anyways, let's move on. How do you figure out the direction of the force? Of course, it will be perpendicular to both L cross B. So one easy way to figure out, of course, is to carry out the operation, and you will know in which direction force is acting. In general, to figure out the direction of a vector, which is a result of two vectors on which you are applying the cross product, we use right hand rule, and I'm always confused about right hand rule. So you can read this, how to do the right hand rule. You can look at the picture. The current is flowing in the index finger direction, magnetic field is in the direction of the middle finger, and your force is going to be in the direction of the thumb. For me, it's generally easy if I see which direction current vector is and which direction B is, then I apply the cross product and I know in which direction the force is going to be. But right hand rule is a very common rule, that is a well established rule, and I'm giving all the explanation over here, and you can find a lot of information online as well as how to apply right hand rule to figure out the resultant vector direction that will be in result of the cross product between the two vectors.